So we're going to start this new topic in decision. There's only a couple that we've got left to do. This one's called critical path analysis, and we're just going to look at what it is in this introduction video, and then we'll develop it further in other videos. So the whole point of critical path analysis is, say you have to complete a particular project. There's a certain number of activities to do to complete that project. You might need a certain number of workers for each activity. And some activities can't be started until others have been finished. So probably a simple example would be to look at a recipe maybe, or like roasting a chicken. The first thing you're gonna do, I mean, you probably might not know about cooking much, but the first thing you do is probably going to preheat the oven. So before you can put the chicken in the oven, you have to make sure the oven's preheated. So what you do in critical path analysis is you look at the way that all the activities are kind of structured, what has to come before what in order for the next thing to start, and then you go into how people can be allocated to complete those activities in the best time possible. Well, the best way to do it is to look at examples. So the first thing we're going to look at is precedence tables, which is here, and activity networks, the most basic kind of to start with, but it can get a little bit more tricky and a little bit more confusing. But this should be straightforward. So here we've got a load of activities in one column, and we've got a load of things saying depends on in this column. And this is what we call a precedence table. It shows what has to precede things before the next bit can start, and that's what this talks about here. So feel free to pause the video and have a little read through that. And you've got all this on the attached sheet to the task. So if we're drawing an activity network for this table, the first thing we do is we start with a point. You can call it 0, and you can call it 1. The numbering doesn't matter too much because we normally put a bit more detail in these, but this is just to get us off to a good start. So first we've got activity A and activity B. They don't depend on anything, so I can do them completely separately. So I can do activity A. We tend to put the activity, different examples do this different ways, but EdXL, they want the activity on the arc and the labeling on the nodes. Okay, so it looks like this. And then we've got B, which doesn't require anything, so B can go off in the other direction, and we'll call that 3. Now if we look at our precedence table, the next one's C. C depends on B, and that means I can't start C until after B is done. So it makes sense if I'm doing my task, my activity network, for the task C to follow the task B. I can't put C at the start, wouldn't make any sense, because I can't start C without B, so B must come before it. It's kind of common sense. D requires A, so we can write D after A. Notice how D doesn't require B. If that happens, then we've got other options, and we'll do questions like that once we've got the hang of this. So D requires A, so it must come after A on that route. E requires D, so E can come after D. And a good thing to do is make sure you use a pencil for this, so you can rub things out and change it if you need to. So E comes after D, and then F requires C and E. Okay, so because F requires C and E, what we can actually do here is we can adjust this slightly. So we put E going down here. Okay, you might want to call this 4, but as I said, don't worry too much about the labeling of things for now. And it's 5, so then we've got E and C. So D requires A, E requires D, F requires C, so F will come out of here because it's then got C and E behind it. Okay, so notice F requires E and it requires C. That's what this diagram suggests. And then G requires F, so we can have G coming out of here, and then H requires G. We only need to show immediate precedence. So obviously H requires every single activity here to be completed. Okay, if H is going to be completed, it needs G. G needs F, F needs E and C, etc., etc. But that's taken into account from the structure of our diagram. And that's how this works. Okay, so we use little nodes and numbers to indicate an event, and we use arcs or branches and we write the activity on them. Okay, it can get a little bit more confusing. They can change the details in the table, and that can change how this works, but that's the basics of it. A and B don't require anything. C requires B, so must come after that. D requires A, so must come after that. F requires C and E, so we can kind of join C and E together to show that F requires both of them. G requires F, and H requires G. And that will be on our activity network. We tend to use straight lines for the arcs as well. And you don't really want them to cross. And also we can't have, we'll come on to this later as well, but we can't have two activities going from one node to another like this. We don't write this either. We'll talk about, if we have to feel like we need to do that, we'll talk about how we do that later on. Let's have a look at 2. So 2 says the production of a new textbook may be broken into activities A to G. And it talks about this, so we're going to draw a precedence table to represent this, and then draw our activity network. So let's draw a precedence table. So in our precedence table, we have our activities, and then we have its dependency, what it depends on. Let's get this out. Just to make it a little bit neater for you. I won't fill all, all the tables, all the lines. Okay, so we've got A to G, so let's write a list of our activities, alphabetical order: A, B, C, D, E, F, and G. Activities A and B, so I'm reading this bit here, do not depend on any other activity. So we can just put a neat little line to show they don't require anything. Both activities C and D can only be started once A has been completed. So C depends on A, and D also depends on A. E cannot be started until B has been completed. So E depends on B. And F cannot be started until C and E. Oops, sorry. So C and E, so we put a comma to represent that there's 2 events there. And G can only begin once all other activities have been completed. So in order for G to start, then obviously I would have done A and B. I'll have done C, which is required for F. So G must mean, so A is used, B is used, C goes into F, so that's used. D doesn't go anywhere else, so G must require D. E goes into F, so that's already accounted for. F doesn't go anywhere, so G must depend finally on D and F. And that's how we build up our precedence table. The principle is really simple, but sometimes it gets a little bit confusing. So just be careful. Let's draw our activity network. So let's start with number 1. So A and B, and again, use a pencil and ruler just in case you make mistakes. We need to tweak it and change it as new information is gathered. Both C and D require A, so I'm going to have C coming out of here, and I'm going to have D coming out of here. And if you take a little look further on, E is going to require B, and F is going to require C and E. So I actually want C and E heading towards the same place. So I'm actually going to switch these round. I'll put the D up here and the C here. Because I know that E requires B, so it's going to come straight after that. But F requires C and E, so now I can join this there. And that means I've got dependency after number 4 on C and E, which is what I want for this F task. Okay, and F doesn't require D or anything, so that's fine. So then F can go up here. Nothing requires D here, apart from the last one, and G requires D and F. So now I can just tweak this again, put my D across here, make that number 5, and then G is going to come out of here to make number 6, and it'll be complete. And you just do a quick check. A and B don't require anything, that's fine. C and D both require A, that's fine because they're both coming out of A. E requires B, that's fine. F requires C and D, that's fine. And then G requires D and F, so that's all accounted for as well. So that's all fine too. Okay, it's easy to go wrong. It's easy to accidentally put the D down here, and then it's going to be hard to connect C and E together because they're going to have to, E's going to have to come up here to try and cross. So try and avoid that, which is why we definitely use a pencil. And the clue is, if you've got an activity which just depends on one, that's going to come straight after that. If you've got an activity that depends on two things, then just be a little bit more savvy, maybe not commit so early on. Get the ones that just require one thing, because if D just requires A, then you know D has to come out of there like this. But you'll see what I mean, you'll get more and more used to it. But there's our activity network and our precedence table for this question, number 2. And let's do the last one, so number 3. Precedence table is shown below, draw the corresponding activity network. So we've got lots of activities this time, so give yourself plenty of space. So A and B don't require anything, so they can go straight off. And let's have a little look ahead at the next bit here. We know that C and D both require A. And then C and D themselves come into play here. So C and D both require A. So let's do 2 here. I'm going to send D off this way again. And I'm going to send C off this way. Okay, I know that C goes into I, so I'm not going to put a link yet for I. So there's D and C coming from A. E and F both require B. So I'm going to need E and F coming out of here. Okay, and again, we might have to tweak this, so we'll just have to see what happens. E and F require B. G and H just require D. So I'm going to need 2 coming out of D, G and H. And G goes into here and H goes into here, so they're going to go places afterwards. So let's have a look at G and H. So we're up to here now. I requires C and E, so we're going to send C now towards here because C and E go together. And if you want, you can put your 5, 6. Doesn't really matter too much about the numbers. You'll see why later on. So there's I is going to come out of here, requires C and D. J requires just F, so J is going to come out of here somewhere. K requires G, I, and J. So I'm in a bit of good luck here because I've got G, I. If I adjust this one, I'll get J, and they're all going to the same place. What number am I on now? Well, I've got 4 down the bottom, haven't I? 1, 2, 3, 4, 5. So again, this is 6. G, I, and J. So K is going to come out of there. K needs all 3, and then L requires H and K. So I need H and K to get L. Oops. So then we've got L. We're done. Okay, and this one, it's once you've seen it, it kind of looks easy to do, but it's not always easy, because if I sent, it might be that you put C above D, because alphabetically you'd probably write C then D like this. But if you just have a little quick scan ahead, you can notice that C goes into I. D doesn't go anywhere else. D goes into its own things. H and G, so it's just going to be, you're just going to want H and G coming out from D. Because I requires C and it requires E, I'm going to make sure that C and E go the same way, and E requires B. So it's going to have to come down from this branch. So it just takes a little bit of fiddling sometimes and tweaking it. But that's how critical path analysis works. And that's what it should look like. So that's just the intro. We're now going to go into when it becomes a little bit more complicated. And I'll probably I'll give you some questions to look at. Well, I've got full questions on this for you to look at anyway. But this is the kind of introduction. That's the first video done. I've just realised I've missed out number 5 on this, but don't worry too much about the numbers. Okay, we're going to be replacing them with boxes soon anyway.